Welcome to Curie Electronics. So in the first part of this video we have solved first 40 questions, and this is the second part. Let's solve remaining 40 questions. That is the question number 41 to 80. What is the cost of digging a pit of cuboidal shape, dimensions of which are 5 meter by 6 meter by 3 meter, at the rate of 35 rupees 35 per meter cube. So it is we have a cuboidal shape. So if you want to dig a volume of this shape, what is the cost? You have to what is the cost? How much does it cost? That is the question. So here first you have to find the volume. Once you know the volume, we know for unit volume how much is the cost. For a cuboidal like this, what is the volume? Volume equal to 5 meter multiplied by 6 meter multiplied by 3 meter. So how much it comes? 5 6 are 30, 30 multiplied 3, 90 meter cube. Now if you multiply by 90 by 35, we should get the answer. So what is the how much is the cost? 90 multiplied by 30, not 30, 35. So how much does it come? It comes to 3150. SAR is a device which has, I'm not again going to explain this all of you know, it's a 4-layer 3-junction device. Identify the electronic component 2N2222. It's a transistor. It's a NPN transistor. In a common emitter configuration, current gain beta is equal to common emitter. So IC is the output current, IB is the input current. So option B is the right answer. In a PNP transistor, the majority current carriers are holes. What is the capacitance of a capacitor that requires a charge Q of 0.5 coulomb to build a voltage V of 10 volts across its plates? So it is based on Q equal to CV equation. What you have to find? We have to find C. So C equal to Q upon V. What is Q value? 0.5 coulombs. V is 10 volt. So what is the capacitance value? 0.05 not microfarad, it's a farad. So it is 0.05 farad. Which of the following types of capacitor is polarized? Generally what we know, electrolytic capacitors are polarized. Also these tantalum capacitors are polarized. Consider an RC circuit as shown below, connected to a voltage source. The value of the resistor is 160 ohm. The capacitor is 1 microfarad. What is the approximate cutoff frequency of the circuit? If an AC voltage source 5 volt 10 Hz to 10 kilohertz is connected at the input, so we are varying the frequency. The cutoff frequency is given by 1 upon 2 pi RC. So here 1 upon 2 pi means 6.28 multiplied by, what is the R value? 160. And what is the capacitance value? 1 microfarad. So we can write it as 10 to the power minus 6 farad, we can write it, which equals 1 upon this 10 to the power minus 6. Once it goes up, it becomes 10 to the power 6. So 3, 4, 5, 6 upon what is there in the denominator? 6.28 multiplied by 160. Now we have to divide this. So usually we can't use the calculator. So what I do, I will consider this 6.28 as 10. So then it becomes 1600 upon, no, not upon, 1600 on the numerator. What is there? 3 0, 6 zeros are there. So these two zeros get cancelled. Now 100 divided by 16, how much will come? 32, 64, 96. So 6. So it comes around 600. This answer comes around 600. Correct? If you divide this, it almost comes to 600. Now if in the options, if you see, option A is 10 Hertz, so it's not 10 Hertz. Option B 100 Hertz. No. Option C is 1 kilohertz, because instead of 6.28 we have taken 10. So if you use the right values and calculate, it will come 1 kilohertz. So 1 kilohertz is the answer. So we can't do so much calculation in the exam hall. So this way you can solve it. Convert the hexadecimal number 1A to its decimal equivalent. So what you do? 1A, it is in hexadecimal to the base 16. If you want to convert it into decimal, we have to multiply. So 1 multiplied by 16 to the power 1 plus A. A means in decimal, what is A? That is 10. 10 multiplied by 16 to the power 0. So 16 plus 16 to the power 0 equal to 1. So 10. So what do you get? You get 26 as the answer. So 26 is the decimal number. In the case of a 100 kilohertz clock frequency, we can enter 16 bits serially into a shift register. So we are having a serial shift register. With each clock, 1 bit will be shifted. So what is the frequency given? It is 100 kilohertz. So what is so from this, if you want to find time, once you know the time period, 16 multiplied by the time period will give the answer. So T equals 1 upon kilohertz, 3 zeros. So it is what come? 10 to the power minus 1. Now we can write it as 10 to the power 5, which equals 10 to the power minus 5 seconds. Or else what we can write it as? The same thing. Let's here 10 to the power minus 5 seconds we have. This means what? 10 to the power minus 5 is there. I will multiply and divide by 10. Then what happens? It is 10 to the power 10 multiplied by 10 to the power minus 6. So it's a 10. What we could say? It is 10 microseconds now. 10 microseconds. So if you multiply, so in 10 microsecond 1 bit will be shifted like this. How many bits are there? 16. So 16 multiplied by 10 microseconds equal to 160 microseconds. How many NAND gates are required to implement 2 input AND gate? I think no need to write. It's 2. We have a NAND gate, that is AB. This output again will give to another and shorted. Okay, two inputs will short and give it. So this is an AND gate, we will get the AND gate function. So it's two AND gates. What is the order decided by a processor or the CPU of a control to execute an instruction? First, what the controller has to do, execute an instruction, it has to fetch, then decode it, then execute. Fetch, decode, execute. In digital circuit, transistors operate in cutoff and saturation region. These all questions are repeated questions. The sequence of operation in which pulse code modulation PCM is done. So for any processing, what you have to do, first you have to sample it. The sampling option is there only in the first. Then sample, quantize it, then encoding. Question number 55. The function of a multiplexer. Multiplexer means what? Many to one. That means many signals we want to transmit to a single channel. To combine multiple data streams over a single data channel. Option B is the right answer. Calculate the frequencies available in the frequency spectrum when 2 MHz carrier is modulated by two sinusoidal signals of 350 Hz and 600 Hz. So it is what, 2 MHz. So 2 MHz we can write it as 2000 kilohertz. Now when you modulate, you have to take the subtraction, addition and the subtraction. That is 2000 minus 0.35. How much it comes? 1,999.65. 1,999.65. Next, what you have to do? We have to add it. If we add, what we get? 2000 plus 0.35. That is 2000.35. So anywhere it is there, 2035, 99.65. Similarly, if you take the 600, what do you get? 2000.6 kilohertz. So option A is the right answer. '57. Solar arrays produce electricity based on the following technology. Photoelectric effect. The acronym GSM stands for Global System for Mobile Communication. A system specification demands 25% derating of electrical parameters. A cable used in it is rated for 10 amp current. What is the maximum permissible current flow allowed through the cable? You see, this derating will apply to make sure the reliability of the components or wires or whatever the things we use for the industrial or space applications. So here 25%, see 10 amp current is there, 25% of derating means 25% of that value we have to minus and consider it. So it is 2.5 amps. 2.5 amps is the 25% of 10 amps. So then what is the maximum? 2.5 amps, not percent. So what is the maximum current then after derating this wire can carry? That is 7.5 amps. The characteristic of a sensor which shows the minimum detectable step of a signal it can measure is called the sensitivity. Sensitivity is the minimum, that's the minimum measurement it can do, minimum signal required to measure it. A 3.5 digit multimeter is capable of measuring up to 3.5 means what? 3 digit will go to 9. 1 digit can change 0 to 1 only. So option A is the answer. This also we have explained many times. So question number 62. The resistance of a conductor of diameter D and length L is R ohm. So what is the equation? So R equal to rho L upon A. So the same thing can we write it as rho, I'll write it here, rho L upon pi d square upon 4. So this is the equation. So if you simplify and write it, it comes 4 rho L upon pi d square. So this is R ohms. Now what is the change in the resistance value when we double the length? So it becomes 2 rho L. So length has doubled, and we are going to pi by 4, we can write it pi by 4. The diameter we are going to make it half. So d by 2 whole square. So what it comes? 2 rho L upon pi by 4 multiplied by d square by 4. Next. So now this 4 we can take it to the numerator. So it will be 2 multiplied by 4 multiplied by 4 upon pi d square. So this 1, 4 and pi d square we can replace with what? Rho is there, okay? Rho is there. This can be, the whole thing can be replaced by R. So now what is the new value? R dash equal to 2 multiplied by 4, 8R. So 8R. So what happens? The answer is 8R ohm. This also we have explained many times. So this should be sufficient. Which of the following wire has best conductivity? All of us know it's a silver. When forward bias to a PN junction increases, the width of depletion layer decreases. Which of the following type is not a surface mounted type component? That is the DIP package, dual inline package. This is a through hole component. What is the typical 4 volt voltage drop of a germanium diode when it is in when it is conducting in the forward bias mode? It's 0.3 volt. Which of the following device is having negative resistance characteristics? That is UJT. Find the voltage across the terminal V if the voltage of each cell is 1.5 volt. So see, this can be found using the Kirchhoff law, current loop, voltage loop. See, when there are 3 batteries and 2 are connected in reverse, these 2 cancels each other and the value is going to be 1.5 volt. This also I have explained how to find it. I'll put the video in the description, or I'll provide it. In which principle does say thermocouple works to measure temperature? There is a Seebeck effect. If unity gain bandwidth of a op-amp is 10 kilohertz, that is gain multiplied by bandwidth equal to 10 kilohertz. Up to what frequency the op-amp circuit works without alternation for a gain of 100? So gain is given 100. What is the bandwidth is the question. So 10 kilohertz we can write it as 10 multiplied by 1, 2, 3 zeros. So 2 zeros cancels. So the frequency is going to be what? It is going to be 100 hertz. So 100 hertz is the answer. So by seeing this, you can understand it is a non-inverting amplifier. So what is the voltage gain of a non-inverting amplifier? That is 1 plus RF upon RI multiplied by V in. So what is the value? 1 plus, what is the RF here? It is 5 kilo ohm, 5 upon 1. What is V in here? See, V in is 1 volt. What is the V in to the op amp? It's a voltage divider. These two 1K resistors act as a voltage divider. So V in is going to be 0.5 volt. 0.5 volt. So 6 multiplied by 0.5 volt. It comes to 3 volt. So 3 volt is the answer. Find the current through the 4 ohm resistor. Here two 16 ohms are in parallel. So it is 8 ohm. Again there is one more 8 ohm is there. Then two 20 ohms are parallel. So it comes to 10 ohm. Then what is there? This is a 4 ohm. 4 ohm. Here is the voltage supply is connected. What is the voltage supply? That is 30 volt. Right. Now 8 plus 4 plus 8, 12 plus 8, 20 is 30. What is I? V upon R, 30 by 30, that is 1 amp. A 3-stage cascader amplifier has a first stage. So first see say total gain is given by A1, A2, A3. So here, so in dB what it is, voltage gain 20 log 10 of multiplication of these three, that is first 10, then 100, for 100 2 zeros, for 1000 3 zeros, 1 2 3 zeros. Now 20, what is the log of this? That is 6. So what is the dB? It is 120 dB. 120 dB is the answer. So option C is the right answer. Number 74. For the gate in the given figure, the output will be, what will be the output? Now for a NOR gate, what we know, when both inputs are same, we will get an output as high. So when that is possible, so this is already connected to 0. So whenever A becomes 0, we will get output high. That means what is when A equal to 0, what is the output? A bar is A complement is the output. So what is the right answer? Option D is the right answer. Correct? Because see, one is for a exclusive NOR gate, XNOR gate, one input is 0. This will give output only high when another next input also 0. So when if you give A equal to 0, then you will get output as high, that is A bar. A bar will get. Output will be A bar. Find the output result of the logic circuit given. So here P, what is the NAND operation, we will get P Q complement, whole complement we will get it. Then here what is there? R complement. Now we are doing the OR operation. We are doing the OR operation. That is P Q complement whole complement or R complement. Complement you can just put it like this instead of bar. So if you with the De Morgan's theorem, if you write this, what we are going to get? P bar or Q or R complement. So what is the answer? So the answer is P bar Q P complement Q R complement. That is the answer. When you test a good diode with a multimeter, it shows what it shows: a low resistance when forward biased and high resistance when reverse biased. What is LVDT generally used for measuring? It's used for measuring displacement. What is to be done to derive velocity from acceleration? If you want velocity, if you want, what you do? We have to integrate it. If you integrate acceleration, we will get velocity. What is the equation of the inductance? That is the question. That is mu a n square upon L. This is the equation. These all are direct and very simple questions. The distance of a geostationary satellite from the surface of Earth is nearly 36,000 kilometers. 36,000 kilometers. So we have completed the remaining 40 questions of this cancelled exam. That is from 41 to 80. So thanks for watching. If you like the video, please hit the like button and share with your friends. Thank you.